Dark matter, a simple explanation. What is dark matter? Dark matter is one of the biggest mysteries in space science today. It plays a huge role in how our universe is built and how it changes over time. Even though we can't see it directly, scientists know it exists because of how it affects everything around it. Think of dark matter like an invisible person walking through a crowded room. You can't see the person, but you can tell they're there because you see other people moving out of the way. That's similar to how we detect dark matter. We can't see it, but we can see how it affects other things in space. The story behind the discovery. The story of dark matter goes back almost 100 years. In the 1930s, there was a scientist named Fritz Zwicky who was studying groups of galaxies called galaxy clusters. He was looking at something called the Coma cluster, which is a huge group of galaxies all held together by gravity. What Zwicky noticed was very strange. The galaxies in this cluster were moving much faster than they should have been. Based on all the stars and gas he could see, there wasn't enough gravity to keep these fast-moving galaxies from flying apart. Yet somehow, they stayed together. To explain this mystery, Zwicky came up with the idea that there must be some kind of invisible matter, providing the extra gravity needed to hold everything together. He called this invisible stuff dark matter because it was dark, meaning it didn't give off any light that we could see. Even before Zwicky, some other astronomers in the 1920s had hints that something was missing. Scientists like Jacobus Kapteyn and Jan Oort were studying how stars moved in our own galaxy, the Milky Way. They also found signs that there might be more matter out there than what they could actually see. As the years went by, more and more evidence piled up. In the 1970s, the scientists named Vera Rubin and Kentford made some very important discoveries. They carefully studied how galaxies spin, looking at something called rotation curves. Here's what they found. When you look at a galaxy spinning, you'd expect the stars near the center to move fast, because there's lots of gravity pulling on them, and the stars at the edges to move slower, because they're farther from most of the galaxy's mass. It's kind of like how planets in our solar system work. Mercury moves much faster than Pluto, because it's closer to the Sun. But that's not what Rubin and Ford saw. Instead, they found that stars at the edges of galaxies were moving just as fast as stars closer to the center. This was completely unexpected and could only be explained if there was a lot more matter in these galaxies than anyone could see. By the 1980s, most astronomers had accepted that dark matter was real and that it was essential for understanding how galaxies and galaxy clusters work. What scientists think dark matter is made of. So what exactly is dark matter? This is where things get really interesting and mysterious. Scientists have some ideas, but nobody knows for sure. First, let's talk about what dark matter is not. It's not made of the same stuff as regular matter, things like atoms, protons, and electrons. Instead, scientists think it's made of completely different types of particles that we've never seen before. The key thing about dark matter is that it doesn't interact with light at all. It doesn't give off light, it doesn't absorb light, and it doesn't reflect light. That's why we can't see it. With telescopes, the only way it affects anything is through gravity. Scientists have come up with several theories about what dark matter particles might be. One popular theory is called cold dark matter, or CDM for short. This theory suggests that dark matter is made of particles that are quite heavy and move slowly compared to the speed of light. Because they move slowly, they can clump together to form the structures we see in space, like galaxies. Another idea involves something called weakly interacting massive particles, or WIMPs. As the name suggests, these will be heavy particles that barely interact with regular matter except through gravity. Some scientists think dark matter might be made of particles called axions, while others suggest sterile neutrinos might be involved. There are even more exotic ideas. Some recent theories propose that dark matter might exist in what's called a hidden sector, or mirror world. This will be like a parallel universe with its own types of particles that are similar to the particles we know, but completely invisible to us. Another theory suggests that dark matter formed from quantum effects that happened near something called the cosmic horizon right after the Big Bang, the moment when our universe began, the evidence that dark matter exists. Even though we can't see dark matter directly, there's lots of evidence that it's really out there. Let's look at the main types of evidence. Galaxy rotation curves. This is the evidence that Vera Rubin and Kent Ford discovered. When scientists measure how fast stars are moving in galaxies, they found that the galaxies were spinning in a way that only makes sense if there's much more matter there than what we can see. Galaxy cluster behavior. When scientists study groups of galaxies, they find that these galaxies are moving around each other too fast to be held together by just the gravity of visible matter. They also look at hot gas between galaxies that gives off X-rays. The temperature of this gas tells us how much total mass is in the cluster, and it's always much more than what we can see. Gravitational lensing. This is a really cool effect that Einstein predicted. When light from distant galaxies passes near massive objects like galaxy clusters, the gravity of those objects bends the light path, acting like a lens. By studying how light gets bent, scientists can figure out how much mass is doing the bending. They consistently find more mass than they can account for with visible matter alone. Cosmic microwave background. This is like the afterglow of the Big Bang that we can still detect today. Scientists can measure tiny temperature differences in this background radiation, and these patterns tell us about what the early universe was like. The patterns match perfectly with a universe that contains about 25 to 30% dark matter. Large-scale structure. When we look at how galaxies are distributed across the universe, we see they form a web-like pattern with clusters connected by filaments and separated by vast empty regions. Computer simulations show that this pattern only forms if dark matter provides a framework that regular matter can follow. How dark matter was created. Scientists think dark matter was created very early in the history of the universe, right after the Big Bang. The Big Bang was the event that started our universe about 13.8 billion years ago. In the first moments after the Big Bang, the universe was extremely hot and dense, and all sorts of particles were being created from pure energy. Scientists think this is when dark matter particles were formed. There are several ideas about exactly how this happened. One possibility is that dark matter particles emerged naturally from the high-energy processes happening in the very early universe. As the universe expanded and cooled down, these particles survived while many other types of particles disappeared. Another recent idea is that dark matter formed in that mirror world or hidden sector we mentioned earlier. In this scenario, the early universe created both regular matter and this hidden type of matter at the same time. Some scientists even think dark matter might be made of tiny, stable objects that are like black holes but formed under the special conditions of the early universe. What's important to understand is that these theories suggest dark matter wasn't something strange that got added to the universe later. Instead, it was a natural result of the conditions right after the Big Bang, just like regular matter was. How dark matter affects our universe. Dark matter has an enormous impact on everything in the universe, even though we can't see it. Here's how. It holds things together. Dark matter acts like an invisible scaffold or framework that holds galaxies and galaxy clusters together. Without it, galaxies wouldn't have enough gravity to keep their stars from flying away into space. The stars would just drift apart, and galaxies as we know them wouldn't exist. It shapes large structures on the biggest scales. Dark matter forms a kind of cosmic web throughout the universe. Regular matter follows this invisible framework, which is why galaxies tend to form in certain patterns and not others. It controls galaxy evolution. Dark matter influences how galaxies grow and change over time. It affects how fast stars form within galaxies and helps keep galaxies stable over billions of years. It dominates the universe. When scientists add up all the matter and energy in the universe, they find that dark matter makes up about 27 to 30% of everything. Regular matter, all the stars, planets, gas and dust we can see, only makes up about 5%. The rest, about 68%, is something called dark energy, which is another mystery entirely. This means that the universe is mostly made of things we can't see or directly detect. Everything we're familiar with, Earth, the Sun, all the stars we see in the night sky, represents less than 5% of what's actually out there. It affects star formation. The way dark matter is distributed influences where and how quickly new stars form. Regions with more dark matter tend to have more star formation because there's more gravity to pull gas together. Why dark matter matters? Understanding dark matter is crucial for understanding how our universe works. Without it, scientists can't explain why galaxies hold together, how the large-scale structure of the universe formed, why the cosmic microwave background looks the way it does, how galaxies and galaxy clusters behave. Dark matter is like a missing piece of a giant puzzle. We can see the outline of where the piece should go, and we know roughly what shape it should be. But we haven't found the actual piece yet, the ongoing mystery. Even though scientists are confident that dark matter exists, we still don't know what it actually is. This makes it one of the biggest unsolved mysteries in science today. Research is continuing around the world, with scientists building more sensitive detectors and running computer simulations to try to understand this invisible component of our universe. What we do know is that dark matter was likely created in the earliest moments of the universe and continues to shape cosmic evolution on every scale. From individual galaxies to the largest structures we can observe. It's an invisible but vital component that makes our universe what it is today. The story of dark matter shows us how much we still have to learn about the cosmos. It reminds us that the universe is far stranger and more complex than it appears when we just look up at the night sky with our eyes. Thank you for watching. Hope this video gave you an idea about dark matter. If so, give us a like. Subscribe for more interesting videos.